Okay everyone, this is section 8.6. In this last section of chapter 8, our goal here is to be able to solve rational equations. So in order to solve rational equations, you can use cross-multiplying to solve rational equations when each side of the equation is a single rational expression. So that's very important. In order to use cross-multiplying, they have to be single rational expressions on both sides of the equal sign. So for example, in example 1 here, we have single rational expressions on both sides of the equal sign. So what we could do is cross multiply and solve. So this is going to be 3 times 4x plus 5 equals 9 times x plus 1. And if we distribute on both sides and solve, I got 12x plus 15 equals 9x plus 9. And if we do some subtraction and combining some like terms, I have 3x plus 15 equals 9, and we can move the 15 over as well. So that we have 3x equals 9 minus 15, which is negative 6, and if we divide both sides by 3, we have that x is negative 2. Okay, and let's check for when x is negative 2 and make sure it's not extraneous. Okay, so I'm going to have 3 over negative 2 plus 1 equals 9 over 4 times negative 2 plus 5. So this is going to be 3 over negative 2 plus 1, which is negative 1, and then 9 over negative 8 plus 5. So this is negative 3. This is 9 over negative 3, which is the same thing as negative 3, and that works out. So our answer is x equals negative 2 after cross multiplying. So when it's not expressed as a proportion, you can solve a rational equation by multiplying each side of the equation by the least common denominator of each rational expression. So we're coming back to least common denominators here. So in example 2, we're trying to solve this equation. So what we can do is look at all of the denominators and try to figure out a least common denominator for all of them. So my least common denominator, if I list them all out, I have an x, a 4, and another x in the denominators. And if I put these together, well, the x's occur twice, but I only need them one. And that 4 occurs once, so I'm just going to use 4x to make a common denominator. So when I do this, I'm going to multiply both sides by a 4x and think of it like over 1, because these are fractions. So now if I think about this, this is 5 over x times 4x over 1 plus 7/4 times 4x over 1 is equal to negative 9 over x times 4x over 1. Okay, so now if we look at each one individually, the x's will go away here, so we're just left with the numerator times itself, so that's just 20, plus, well, the 4's can go away here, and it's still all over 1, so this is just 7x if we multiply straight across, equals, well, the x goes away here, the denominator's still 1, and negative 9 times 4 is negative 36. And we're just going to solve this equation, so I can move 20 over. So we got 7x equals negative 56, and if we divide by the 7, x will be negative 8. And we could check this as well. So whenever x is negative 8, So this is going to be 5 over 8, negative 8. And plus 7 over 4 is got to be in negative 9 over negative 8. And in the calculator, when you add 9 or 5 over negative 8 plus 7/4, you do get a positive 9 over 8. And when you set these both equal to each other, 9 over 8 does equal itself, so that's good. And example 3, we're going to do the same thing. We're going to start out by figuring out a least common denominator for these. So if I think about LCD, well, my denominators right now, if I think about this over 1 over 1 is still 1. So I have a denominator of 1, I have a denominator of x minus 5, and of x. Okay, so we put these together, I'm going to be left with figuring out here x minus 5 and the x do occur. So if we put these together, this is x times x minus 5. So here's my least common denominator. So that's what we're going to have to multiply both sides by. Okay, so if we think about this first one, this is 1 over 1, and then times, again, these are fractions, sorry, x times x minus 5 all over 1, minus, because we're subtracting here, 8 over x minus 5 times x minus 5 all over 1, and then equals 3 over x times x minus 5 all over 1. Alright, so now if we think about stuff that they can cancel out, okay, nothing can really cancel out of the first one. It's all over 1 times 1, which is still 1, so this is just x times x minus 5. In the second one, however, the x minus 5s do cancel out, so we're just left with multiplying the numerators together, which is just 8x. So minus 8x equals, and then after the equal sign, the x's cancel out, so I can multiply straight across here. So this is 3 times x minus 5. Okay, so now it's just distribution, so I can distribute. So x squared minus 5x minus 8x equals, distribute here, 3x minus 15. I can combine some like terms to make it negative 13. And I'm going to have to combine some stuff in order to make it factorable. Okay, so I need 0 all alone on the right hand side, so I'm going to subtract 3x and add 15. So this is x squared minus 16x plus 15 is 0, and this can factor. So I need 15 up top and negative 16 in the bottom. And our factors here are negative 15 and negative 1 that multiply to make regular 15 but add to make negative 16. So this is going to be x minus 15 and x minus 1 is equal to 0. And remember that we split and solve these to solve for our x values. So x minus 15 equals 0. If we add 15, x is 15. And then on this one, we add 1 to both sides, x is 1. Excuse me. So now we're going to check these individually. So being 15 and 1. Excuse me. So now, if I check here, this is 1 minus 8, 15 minus 5 equals 3 over 15. So 1 over 10 is 3/15. But 1 I can write using a denominator 10, or 10 over 10 minus 8 over 10 equals 3/15. Or this is 2/10. And if I divide by 2 here and divide by 3 here, I got 1/5. And this is also 1/5. So this one's good. And if I check if x is 1, I got 1 minus 8 over 1 minus 5 equals 3 over 1. Okay, so here's the simplified. And now I can write 1 using -4s as -4 over -4 minus 8 over -4. -4 minus 8 more is -12 over -4. And that does make a 3, because two negatives divided by each other makes a positive. So these are both our answers to example 3. So positive 1 and 15. None of them were extraneous. In our last example here, example 4, we're going to solve this last rational equation. Okay, and then check for any extraneous solutions. So first off, let's think about our LCD. So our LCD out of this stuff, oops. So I have a denominator of x minus 3, an x squared minus 9, and an x plus 3. But this one is a difference of squares. The x squared minus 9 is really x plus 3, x minus 3 factored out. And when we compare these all, the most amount of times is x plus 3, x minus 3, so that's what's going to be multiplied on both sides. So I'm going to multiply the left-hand side by x plus 3, x minus 3 all over 1, and also the right-hand side. So x plus 3, x minus 3 all over 1. So first off here, to start it out, this is 6 over x minus 3 times x plus 3, x minus 3 all over 1 is equal to 8x squared all over x squared minus 9 times x plus 3, x minus 3 all over 1. Okay, and then minus 4x over x plus 3 times, again, x plus 3, x minus 3 all over 1. And now if we go canceling out some stuff, well, in this first one I got x minus 3 in both of them. And if I multiply straight across, this is just 6 times x plus 3 equals, and in the second one, x squared minus 9, that's still a difference of squares, which is really just x plus 3, x minus 3. So these both cancel out here. And I'm left with 8x squared. And in this last one, if I keep the minus on it, x plus 3's do cancel out. So we're left with what's multiplied together in the numerators, 4x times x minus 3. And if we go simplifying, we could do some distribution here. So 6x plus 18 equals 8x squared. And distribute here, negative 4x squared plus 12x. And we're going to combine some like terms. So this is 4x squared plus 12x on this side. And we're going to make a quadratic equation that can be factorable. So we're going to subtract the 6x on both sides and the 18 in order to make 0 on the left-hand side and avoid any negatives. So this is 4x squared plus 6x minus 18. And notice that before we go to doing the x method or anything to factor, these all can be divided by 2. So if we divide the whole thing by 2, we got 0 equals 2x squared plus 3x minus 9. And that can be used in the x method. So if we multiply the first times the last coefficient, that is negative 18. And our middle coefficient is 3. And the factors of 18 that can add the 3 are 6 and 3, because we need the negative on the 3. And we started out with a 2 as our a, which can be divided by 2 and made into x over 3 on this side, and 2x minus 3 over here. So x plus 3 and 2x minus 3 equals 0. And if we split and solve, we got x plus 3 equals 0, or x equals negative 3. And if we add 3 over here, and divide by 2, this is x equals 3 halves, or 1.5. And again, let's check these. So if I check first, x being negative 3, I get 6 over negative 3 minus 3 more. Plugging in a negative 3 here. Okay, so this is 6 over negative 6 equals, this is 72 over 0, and then minus negative 12 over 0. But notice how these are over 0. These are undefined, which means it is extraneous. So we cannot use x being negative 3. It is extraneous, okay? So that is very big to point out because of these zeros. And if we check for, x being 3 halves, okay, this is 6 over 3 halves minus 3 equals 8 times 3 halves squared, all over 3 halves squared minus 9 minus 4 times 3 halves, all over 3 halves plus 3. And even though these are fractions, I got negative 4 on the left-hand side when we put that in the calculator. And this simplifies the negative 2 and 2/3 and minus 1 and 1/3. So this is really just negative 4 evaluated on the right-hand side, and negative 4 does equal negative 4. So this is actually our only true answer here. X is 3 halves. That's our only answer because of this check mark there, or this verification. So x here is only 3 halves. That's our only true solution.